Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called Find Distance in a Binary Tree. We were given the root of a binary tree and two integers p and q. Return the distance between the nodes of value p and value q in the tree. And the distance between two nodes is the number of edges on the path from one to the other. So here's an example. We have a tree rooted at 3, and we have a value of 5 and 0. So we have 5 here and 0 here, and we are going to find the distance between these two nodes. So it's going to be 1, 2, and 3. Okay. So here's another example here. We have this tree, and we have 5 and 7. 5 and 7 are in this same left tree. So the distance is 1, 2. Okay, and there'll be more examples. We have 5 and 5. So clearly the distance is 0. So this, how do we approach this problem? Find distance in a binary tree. We can see from our example that first, we have to go through the common node along the path. Here, the common node along the path, or itself. Okay, so it is quite natural to think about finding the LCA first, which is the lowest common ancestor. So here in this example, 5 and 0 has the lowest common ancestor of 3. And we can calculate the distance between the lowest common ancestor and each node, okay? And then we can add them together, okay? So yeah, that makes sense. So how about this example? Our lowest common ancestor is 5. So 5 to itself, the distance is 0, and the distance between 5 and 7 is 2. So this also works, and this also works, okay? So let's write it out. First is to find the LCA, second is to find the distance. Okay, so we can write something out like this. We have to find the LCA. So that's going to involve root P and Q. After finding the LCA, we can find the distance of each node to the LCA. So we can get distance, okay? So first it's going to be root, LCA, and P. Okay, so the distance actually is the depth. So I'm going to change the name here. And originally we start from 0, okay? And also this works for the other side, Q and 0, and we just have to add them together. All right. Okay, so next, let's find the LCA. We're going to return a tree node, and the name is called find LCA. Root, integer p, integer q. So if we find the value to be the root, or equal root equals to null, in either case, we can return root as our LCA. Otherwise, we have to find whether it exists in our left subtree or the right subtree. So find LCA, and also works for the right side. Okay, so if we got two not null results, that means we are standing at the LCA. The root is the LCA. Otherwise, we'll just return the one that is not null. Okay, so that makes sense. And next is to get the depth, okay? So we have a tree node, we have an integer, we have a current depth. So if our root equals to null, we'll return 0 because there will be no height related to it if it's null. And if we find the number that we're looking for, we can just return its current depth. Okay. Otherwise, we go to the left side and the right side to find it. So the left side will return the depth of the current, the maximum depth of the next one. So let's take a look at example here. So we have this one, right? And we call this getDepth. We go to the left and we make a call again. Here we are at the leaf node, and then we make another left call, but now we have a 0. And here we have another 0. So when returned, this one will have a depth of 0, right? So this one returns 0, this one returns 0. So this returns 0. And when it goes up, since it is not null, we'll add 1 to the upper side. So here 5 will have a height of 1 from the left subtree. Okay, so left is getDepth and current depth plus 1, also for the right side. And what are we going to return? We're going to return the maximum depth from both left and right, okay? Yeah, so that's basically how we approach this. Let's take a look. Okay, I think it passes all the test cases. So for the complexities, since we're traversing the tree, it will be ON. And for the space complexity, when we get the LCA, it's going to be like, if it's a highly skewed tree, like a linked list, at worst, it will be O of N. Okay, let's submit it. Yeah, I think it passes all the test cases. Thank you so much for watching. I'll see you in our next video. If you like the video, and please just like and subscribe to my channel. Thank you.